So this is me. I don't have the same hair anymore. That kind of changes from conference to conference. I am a developer, definitely a nerd. I do love automation. Also a gamer, and very much so ADHD, getting me down these rabbit holes like this. This is my colleague, and that was the end of the stage.
Right. Yeah, my name's Awar. I'm a senior engineer at Supersteria. Somewhat of the same case with having different hair for every conference. And also kind of sleep-deprived engineer. I usually introduce by saying I'm a senior engineer, but I'm also the person staying up at 2 a.m. and actually diving into things like what we're about to talk about.
Like last night when we fixed the RBAC for our demo today. So we'll have a live demo at the end as well. But first we'll go through kind of the theory around securing endpoints in MCP. Like we have been securing our REST endpoints for years now, and we're kind of getting pretty good at it. But we still need to treat our MCP endpoints just as we treat our REST endpoints. So the question is then how are we managing our claims, our tokens when it comes to the new MCP? And just to go through, just to mention it, we have three parts of an MCP server. We have the resources, we have the prompts, and we have the tools. We'll mainly be talking about the tools here today. That is kind of what reflects the endpoints we're used to dealing with in the REST world as well. Prompts are just kind of suggestions we put up for our users or our agents, and resources are more a description of what's available in our server. So when we talk about security in the MCP space, we usually talk about it in 3 layers of security. We have the web layer, which is your kind of basic IT security level, where you have the network layer security. We have the AI firewall, which is kind of classifier guardrails. I will mention a bit more about that as well, but we are kind of checking our inputs, our outputs. And then we have the data and tools layer, where we have our RBAC, which we will mainly be talking about, but let's just jump into just looking at the AI layer first. That kind of entails data categorization, content filtering based on categories, threat detection like harmful or benign requests. These are more on the input side of our MCP server, and also spam detection, sentiment analysis, and stuff like that. Guardrails are more of a predefined set of rules to ensure that our AI systems operate in a way that we find as acceptable boundaries. They effectively act as constraints to prevent the AI from performing actions that should be harmful or unintended. There we have the policy enforcement, we have the output regulations, our ethical constraints, response filtering, we have our own models, analyzing the input versus the output, anomaly detection to trigger alerts, or automatic mitigation, moderation, and stuff like that. Usually we will use software for this. We don't want to make all of this ourselves. We have Akamai, a Belgium company, has software for this. Cloudflare launched their AI gateway not too long ago as well. But we will mainly be talking about the data and tools layer before we kind of head into the demo as well. And what we're talking about here is the defense in depth. Does your APIs have access to only what it's supposed to have? Does your users have access to only what they need? So let's see how we can use our RBAC in our servers. My code examples will be in Go, but that doesn't matter too much. So say we have a Java token or we have an API key with their scopes, with their claims. We have in the model context protocol.io or from the SDK that they have out on GitHub. We have at least built-in security from the beginning. So they kind of did the base work for us, where we just set up everything in the scaffolding, set up our add tool. We have some methods we have to add in for our validation of the Java tokens, and then we get the token info available in our tools when we're making our own MCP servers. The SDKs are the same for C# when you then define your the scopes and the claims in the initial service builder as well. And then the question is, how are we using our own claims or our own tokens here? This is kind of the usual flow. You go to the auth server, you get your token, you push that over to the MCP server, and it acts on your behalf. That's kind of just giving the server your key and say, hey, do whatever you want with it. I'll touch a bit into why this is so much different than we do on the REST servers today as well. But this will basically put all your names in the log saying you did it. The other alternative is kind of to get the give the MCP server a universal key and say do whatever. Then you risk actually doing more harm that you are allowed to do. So how can we handle our keys, our secrets, and our RBAC? We can, like I showed, you can reuse the token. We can use a token exchange, which is defined in the RFC 8693, which is kind of the most correct way of doing it right now. And then we also have the alternative to do some type of elicitation. And we'll see, because you don't really know what your agent is doing, because you're asking it to do kind of something undefined. So you have to know that when you prompt your agent, you just don't wreak havoc in your systems. So this is the RFC 8693 token exchange, where you get your token from the auth server, which you use to send to the MCP server. The MCP server will use the security token service to get on behalf of token, which is kind of just your token wrapped in another token. And then the question is, did we solve a lot, or does this only have, like, the only thing we solved is it will show in the logs that this was done by the MCP server on behalf of you. It will still generally keep the same access as you had as well. So how can we solve this? Another way to do this is use some kind of elicitation. So we start out in the same way. We get our token, send that to the MCP server. Then the MCP server tries to do something on the back end, but your token is only valid to talk to the MCP server, not actually doing anything. So it will respond to the MCP server with, no, you need this this audience, you need this scope, and then you get some information back. And then it's up to the agent, which you control, what I call the MCP client. It's also the agent that you're talking to. Are we going to get a new token that can actually do these things? And if yes, we'll pass this on. So the question is what we do here. And if you take my jokes, you're just too old, just as me. Because here we get to the point where are we going to ask the user if it's okay to do this or not? So you have this talk with the bot, you get the questions back. Okay, I want to do this. Is that okay? Can we perform this action? And then you're ending up with what we call confirmation fatigue, because if you're asking the user every time you want to do something if that's the right thing to do, so it's kind of a balance, trying to find out how you can ask when it's important and not when it's not. And I know I'm raising a lot of questions and a lot of problems and not a lot of answers. But I think it's you have to have that in the back of your mind when you're building up your own service for it. So you kind of have to talk about the access control and how you handle it. The question is, are we using RBAC, like role-based? So the agents need to be the finance manager in order to check the budgets. But then it also gets the possibility to get information about payroll, about forecast access, etc. Are we looking for attribute-based access control instead? The problem is then you will be handling thousands of attributes for your clients. Are we just working with impersonation? How will we log and manage the accountability? You will log the user, not the agent. And then has been proposed something called task-based access control. And is that the solution, where the agent has the right to do this task on behalf of? It kind of just matters if this aligns with your existing access control. So you have to have a view on how your access control works today. And if this even fits in any way. And I said I'll come back to why this is very different from the usual REST API access controls, because in our conventional APIs, they're usually tied to a button on the website, or we have made a task list we're going through, so we know what endpoints it will connect to at any time. But when it comes to talking to our AI agent, we kind of just give it a task that will, or we give it the goal of what we will, where we will end up, and it will decide what tasks to do on the way to the goal. So you don't have the same control in what is being called. So like I was in a project now recently as well, and they were saying, but we're kind of afraid that our agents will do things that our developers don't do today. They have the access, but they don't want actually push the buttons. So they don't really have the control over the access control for their developers, but they trust that the developers won't do anything stupid, so it's okay. But now that we're going over and coming to the agents, we don't know what choices the agents will make for us. So that was kind of the first question. Maybe we should look at the access control first. But let's change gears a bit. Go from the purely technical to the more, I'll say, structural and architectural. So when setting up your MCP servers or relaying public MCP servers, what kind of pitfalls are we looking at? What will we try to avoid? Should we take all our REST APIs, make them into MCP endpoints or MCP tools, easy for everybody to access? And we're back to, does the access control model actually fit to the use here? is it possible to use the endpoint as a tool for an agent? And it's great making our endpoints more available, because in MCP server, like the kind of standard that have emerged as well, you have the dynamic discovery, you can add a new endpoint, and then the users can subscribe to the changes of your API. But do you have the proper data filtering? Can your data be available even if they're not supposed to? There might be a lot of complex implementations, and if it's not well enough documented, the agent might use the endpoint wrong. You can think you don't have to document your system as well because it's going to be used by an agent or by an automatic system instead. But actually, it's much more important for you to document how it's used, how is the intended use of the tool. And can your security handle it? It's something called reversed prompt insertion. Like, does the external MCP server you're accessing trying to instruct your agent to do something and do a follow-up? Do you do a run SQL or fetch URL on whatever you get back from the MCP server? Something called autonomy escalation. So you kind of get this loop of your agent and the MCP server just talking to each other, where the server ends up instructing your agent to continue. And you have the possibility to use a team of agents or sub-agents, or like it's even built in the newest Claude 4.6 now as well. And then how is the access control handled in depth if you have agents talking to agents? And how is the access handled through those layers? So you risk ending up losing control. Either you're stuck with the wrong access, or giving your agents too much freedom, and you will equally end up in the post-apocalyptic chaos. And we're back here to your agent or your MCP server wreaking havoc in your server as well. But it's also important to think about, we have all this technology, but we also have all the people that are using the agents. There are some culture changes. We need some routines when we are using external or internally hosted MCP servers. When we let our developers use LLM agents in their Visual Studio Code, and those should be in place before we just let everybody loose. So it can be a good idea to kind of create a classification model. This is just an example. When you kind of have the publicly accessible MCPs, they don't have any read to your internal data. They don't have any write access. You have your level 1s, where you can read your internal data. You still don't have any write. You have the level 2, which has kind of a moderate read-write, and the last one that should maybe not be accessible through MCP servers at all, which have the opportunity to do production changes. And then you'll need a kind of a scoring model to see, we have this MCP server we want to use. We think it fits into this classification. We do the scoring. We see, does it even match? Or do we have to move it to another classification and then use it in another way? We have other guidelines telling us how to use that as well. And generally have some guidelines for safe use of agents available. Usually make them with your developers, which will include things like accepted use cases, requirements for access control, risk assessment checklists connected to the classification and scoring, incident management, how do we log, how do we handle incidents, compliance, privacy, regulations, how do we document, etc. And another thing that you have to think about when you let your developers lose on VS Code, adding all these MCP servers and tools. It is the context window of the agent. If they add a lot of tools, the agent will actually forget what they do. They can't hold all that information anyway. And we have a solution for that as well, maybe, in the demo.
Do we?
Yeah.
Okay.
It's
It's
demo
my
time.
turn now. I get to talk.
Yes.
Fantastic. And let's see. I am going to mirror my screen, and that's hopefully visible. Okay, so I think for transparency's sake, we should probably mention that we've held this demo a couple of times with a couple of different iterations, and up until this one, we've usually hosted this solution locally, and then we chose to go over to Azure for this specific demo. So I'm gonna showcase a couple of things, explain a couple of things, explain why we've done it the way we've done it, so maybe you can get some value out of it. There's a project which is open source. It's a cloud native project. You can find it in the CNCF landscape. Most people who are interested in MCP probably have heard of it already. It's called KAgent, and there's also kind of a sister solution to KAgent, which is called KMCP. The point of KAgent is to be able to host your own solutions. So you can host your own models, you can host your own MCP servers, and so on and so forth. So I'm going to showcase a couple of things just to like get the point through and explain why we're looking at this like at all. And then we're going to look at some security stuff as well related to that. So the biggest part of KAgent is your agents and also your MCP servers. A couple of things to note here. The MCP servers, when you set them up, you have a couple of options on how to set up the MCP server. Specifically, you can host the MCP server locally. So for instance, I could boot up a server in a pod, which I'll show, and then I could just connect to that whenever I want the AI to actually have some kind of tool. The other alternative, which you'll also see on some of these solutions, is that I could use some kind of remote. So I could use GitHub, for instance, GitHub's MCP endpoint, and then I could authorize to that and also connect to it and get the tools from the MCP endpoint. When you do set up the MCP server, they give you multiple tools, which is what they're called in KAgent. Some solutions have different names for them, but the point is that they have a single skill which the MCP server provides. The point of that is when I go to build my agent, I could decide whether it should get the whole stack of tools or a single tool. So for instance, when we look at, let's see if I can find it. When we look at, I'll just go look at the agents. I think, there it is. So I have a Kubernetes agent. This is, I think it's the default one, but it's been bumped up a bit. It has a bunch of tools when I go to the configuration. So this is both if you're familiar in Kubernetes, this is both a CRD, so it's a custom resource in Kubernetes which you can configure, but you can also just do it in the provided UI, which we're looking at now. I can choose what kind of model I want, which we're also going to look at. And then I can also configure the tools which the agent has accessible. And tools are classified into their MCP server, and they're also classified into agents. So I can do something called agent-to-agent, well, it's called agent-to-agent skills, which means I could have one agent speak to another, and then say, for instance, create a difference in who is responsible for what. So I could have one agent which is responsible for Kubernetes, I could have one agent which is responsible for observability, and then I could have a third agent talk to both of them whenever there is a request. And I could also go on and let's go to one of these. I could have one agent which, for instance, has multiple Kubernetes skills, but then also can use other agents with more skills or more in-depth skills to provide multiple layers of abilities. And then I could, for instance, there's a skill which allows you to delete resources. So if I want my agent to be able to delete resources, then I could give that, or I could remove it. And I could say, no, you're able to create resources in Kubernetes, but you're not able to delete them. So further moving on, I mentioned models. You have the ability to host your own models. There are multiple things there. So one thing is you could use an API key to a third-party provider. Which you'll see here is you have multiple options, but you have Claude, you have the OpenAI models hosted on Azure, and then you also have Gemini, and you have GPT directly as well. But then you also have the option to use Ollama, which is probably one of the more interesting things about using K-Agent, because in theory, you could host all your own models, all your own MCP servers, and also all your own agents, meaning the whole stack is in your network, in your solution. You could, in theory, also air-gap everything if you wanted to do so. And then when I have my agents and models and I want to configure one of these, there are multiple ways of doing it, but the simple idea is you have some kind of agent configuration. So if we go to let's look at Helm, for instance. I have some kind of declarative description. This is so that, one, I know what the agent is actually used for, but the other part of it is whenever I use agent-to-agent skills, they can look at the description and they can say, oh, that's a useful agent. I'll use that whenever I have a need for Helm, for instance, or whenever I have a need for observability stack. The other part is you can provide custom instructions. So Manfred did mention elicitation. You can have implicit elicitation. A K-agent doesn't give you the same button you do in VS Code where you actually say, yes, keep these changes, or yes, actually apply that. But you can have implicit elicitation in that the model asks you, do you actually want this or do you want this change? And you can provide like an infinite number of instructions to the model. And then you can also choose what the model will actually run on. Then there are a couple of other things. So I mentioned that this is in Kubernetes. I'm not going to go very into depth about Kubernetes because if you're not familiar, it doesn't really matter. The point is it's a cloud. It's your own private cloud, more or less. However, because Kubernetes is really expansible and you have a lot of options, you can also use things like Kyverno. So, for instance, if you're not familiar with Kyverno, it's basically policy as code. So I have the option to create policies and then deploy them, and I can use that to manage my resources. So even though K-Agent isn't very mature, let's say, it's still quite early in baby steps. I can create tools around it to provide more secure support for it. Another thing you have the option to do, so this agent is actually on the internet. Well, the application is on the internet. And one of the things we did was provide OIDC, such that even though it's publicly available, you still can't authorize into it. Is that a thing that K-Agent supports? No, it isn't. You have to make it yourself, but there are tools you can use to inject such support on your own. And then one of the reasons we wanted to use Azure, well, first of all, compute is a lot more simple, but you also have a bunch of supporting tools. So for instance, I have pre-made dashboards, which I could use with managed Grafana. And I can also use things like Istio. You can do that in default Kubernetes as well, but the point is that this is quite a bit easier to manage, especially if you haven't done it before. So I could, for instance, let's see, let's remove that, select agent. And there I have some metrics about all of my models and what they actually do. One more thing, back to K9S. So I mentioned that these are resources, right? So the MCP servers, for instance, are codified, if it loads. Meaning, in theory, I could have all of this in code. So each of these are just YAML code, which has its own documentation, and you can define this in code and then use a tool like Flux or Argo CD if you're familiar with that, which you then can use to reuse these models. So if I have some pre-made configuration which I find useful and I want to reuse some other place, I could codify all of it and then use it again for another solution. Let's see if I actually can write. Okay. One more thing, talking about code. So this repo isn't public, but there is a demo repo which actually is public, which is basically the same code. This will get updated at some point. But the thing we've done is we've tried to codify absolutely all of the main resources we use. So we have some agents which are predefined. We have our models. We also have tools like Kivano, and we've made some configuration which can be reused, like policies, for instance, which we find useful. So when we do host these solutions, we actually have the ability to provide guardrails instantly without like having to faff around and find out what to actually do to support them. Am I forgetting anything? I think we've been through most of it. Usually we also showcase that the model actually works and it does talk. I don't think that's very relevant for a security conference because we have other options and we have other things to look at. But the point is that when you have the ability to host all of the model stack on your own, you can secure the model stack as well. No.
And also, since the models run each like their own, run as their own pod in Kubernetes, you can technically have different RBACs for the different agents as well. Right. All agents are available as either agent-to-agent communication or as actually MCP servers. So you can create an agent, and that was what I was talking about earlier as well, so you can come back to that. You can create an agent that uses, for instance, the Kubernetes MCP tool, and then you can remove all the tools you don't want it to use, and then give this as an MCP server to your developers, meaning they will get the access to the Kubernetes MCP, but without the things you don't want them to have access to. And that will actually get the available tools down, making the context window able to handle more as well.
Yeah. I also just quickly wanted to tie all of this together a tiny bit. So Manfred did showcase this drawing earlier, which is your MCP client, your auth server, your MCP server, your API server, and STS as well. We can simplify that a tiny bit by calling the MCP client, in this case for KAgent. The MCP server is hosted by KMCP, and then your API server is whatever service you want to be behind your MCP server. And then you also probably have some sort of auth server as well in front of that. The point of this is you can kind of create a flow in which you are either the owner of most of the stack, or you have such an overview of what kind of communication is happening between your different solutions that you actually have the ability to secure those endpoints. Be that with RBAC, which we've talked about a bit, or if it's your agents themselves, you can use some sort of A2A skill or task-based access control as well. And KAgent actually has a tiny drawing of how their communication flows within their solution. So we haven't talked about it, but they do have a CLI, which you can use to install if you want to try KAgent on your own. It's a brew install KAgent and then KAgent install, and you have a KAgent running in a couple of minutes. And then they also have the dashboard, which is part of the UI we've looked at. And their backend and controller is more or less just this leader election and choosing and deciding what kind of operation is going to happen. And with that, I think we're finished.
Now I have a lot of time. I hope you have a lot of questions. Almost 20 minutes left. Are there any questions? Or is there anything you want us to show more in depth of what we showed so far? Yes.
So just to repeat the question was how do we use it, or if we even use it day to day. We do use it, but we use it for different purposes. Most of it is to kind of showcase, so we do consulting. So we showcase what the market can provide, and also what's possible to do with, for instance, your agents. What kind of communication you can use, what options you have for MCP servers if you want to self-host your own MCP servers. And there are some who have actually done that implementation as well.
Yeah, I think as we talked about as well, using this as a proxy to add an authorization layer that doesn't exist elsewhere. So even if it comes down to limit what kind of tools you want your users to be able to use. For instance, like the GitHub MCP server is either, they have two endpoints. It's one read-only endpoint and it's one do everything you want endpoint. Maybe your developer needs to have elevated possibilities to do changes in your GitHub repos or in your Kubernetes cluster, but maybe you don't want them to be able to do that through the MCP server that they add in Visual Studio Code, because that's where they sit and talk to the agent. So then you can use KAgent as a proxy. So they, instead of using the GitHub MCP API, you use our GitHub agent in KAgent as an MCP server instead, that has less access to do those big changes in the repos, for instance.
If that's how we would apply enterprise controls, yeah, it could be one of the ways. Just to kind of clarify a bit more as well, one of the reasons I began looking into KAgent is because the existing enterprise solutions, like if you look at GitHub Copilot or Microsoft 365 Copilot or whatever solution you want, most of them are cloud-based, which is really nice and dandy. And then you have some enterprises where that's not a thing you actually do, like they don't have cloud solutions. So you have to provide some sort of support or some sort of solution for people to host their own MCP servers as well, and also their own agents. And Usually I find that most companies tend to just boot up a machine with a bunch of GPUs and then try to make it work and train their own AI.
Yeah, so it's both to as a proxy layer or security layer for your MCP servers. You can host your own MCP servers. I have a customer that are hosting their own MCP server that can make draw IO sketches. So it kind of doesn't do anything outside, but is not a publicly available hosted service, but you can host it yourself. But also, like Awar mentioned earlier as well, companies that have air-gapped systems, they have this whole enterprise system is not connected to the internet at all, or if you are on places that are cut off from communication, like if you're out on the big ships or trains or whatever, you are actually able to host your own LLM models. And of course, you're sure that your data will not be shared with the big cloud providers like OpenAI, like Google. You will keep all the communications within your own kind of boundaries and network.
Good question. More questions?
Yes.
Yeah.
So the question was how to keep your agents from being too helpful and download tools. That is kind of the one of the good things about how we're hosting it as in Kubernetes as well, because you can control the RBAC of the agent itself, so you might not be able to download anything and to run it.
And you also have the agent hosted on a pod, which is like basically a tiny VM. So in theory, I could also just close the network, and I could say that, oh, you can't reach GitHub, right? You can't comment on API because you can't reach GitHub at all in any way you try to find. And you also have the option to limit the uses of MCP servers because they are well, I want to say asynchronous, but more like aconnected. So I could limit the amount of skills, I could limit the network, and I could also limit the role-based access control.
And using solutions like Cilium or other kind of network control operators or controllers in Kubernetes, you can also limit what it's actually able to connect to. So even if it can think that it can download a CLI or download something, it's not able to talk to anything else but the endpoint is supposed to talk to anyway.
Good question. Very good questions. Any more?
And also, as I talked about in the beginning, where we have the 3 layers of security with the network security, the AI firewall, and the role-based access control. The AI firewall should be applied to both inbound and outbound, so you will also sanitize the responses you will get from the external services. Like I was talking about the inverted prompt injection as well. So you make sure that the external services you use are not able to instruct your agent and be very helpful in that way. Any more questions? It gives you a lot of time to drink your coffee. Thank you everybody for joining our talk.
Thank you.